In the depths of our solar system, a recent image of Pluto has sent chills down the spine of the scientific community. This image, a gift from NASA's New Horizons spacecraft, has unveiled Pluto like never before, making the distant planet feel slightly less alien and a whole lot more intriguing. Upon closer look, the image is a canvas of strange, eerie features that seem to defy everything we thought we knew about this icy world. Imagine standing on the edge of an unexpected mountain range, its peaks reaching out to the stars, casting long, dark shadows across vast, flat plains that stretch as far as the eye can see. Now shift your gaze to the peculiar crater formations, their origins unknown, their purpose a mystery. These formations, so alien, so distant, are not just geographical features. They are clues waiting to be deciphered, holding the keys to Pluto's past, and possibly its future. These unearthly formations have sparked a myriad of questions and ignited a renewed interest in this distant icy world. As we delve deeper into the mysteries unveiled by this image, we begin to grasp the complexity of Pluto's geology. The intricate formations on this distant dwarf planet have sparked a multitude of theories among the scientific community, each more fascinating than the last. One such theory centers around an intriguing phenomenon known as cryovolcanism. Unlike the fiery eruptions we're familiar with on Earth, cryovolcanoes spew out a lava of icy substances like water, methane, and ammonia. This could potentially explain some of the unusual surface features we see on Pluto. But the mysteries don't stop there. Beneath the icy exterior, scientists suggest the existence of a subsurface ocean. This ocean, believed to be a mixture of water and antifreeze-like substances, could be responsible for the tectonic activity we observe on Pluto's surface. It's a prospect that adds another layer to the enigmatic nature of this celestial body. And let's not forget about the potential presence of organic compounds. While the word organic might instantly make you think of life as we know it, in this context it simply refers to carbon-based molecules. These compounds, found in many parts of the universe, are the building blocks of life as we understand it. Their possible presence on Pluto opens up fascinating questions about the conditions necessary for life to form. Each of these findings carries profound implications. They challenge our preconceived notions about what it means to be a planet, and they open up new horizons of possibility. Could there be life, however primitive, on Pluto? We can't say for sure, but these discoveries certainly give us food for thought. The more we learn about Pluto, the more it seems to defy our expectations, challenging our understanding of planetary science. The image of Pluto, though fascinating, also reveals some scary secrets about this distant planet. As we delve deeper into the mysteries of this celestial body, we find ourselves confronted with implications that are as mind-boggling as they are terrifying. Imagine, for instance, the harsh conditions on Pluto. The extreme cold, with temperatures dropping to -375 degrees Fahrenheit, is enough to freeze anything in an instant. Then, there's the potential for catastrophic geological events. Pluto's surface is constantly changing, with vast plains of nitrogen ice that can shift and crack, causing huge chasms. Imagine an earthquake here on Earth, and then magnify that by 1,000. That's the kind of geological activity we're talking about. And here's the kicker. These features aren't unique to Pluto. They could exist on other celestial bodies in our solar system. This raises existential questions about our place in the universe and the potential dangers that come with space exploration. As we uncover more about Pluto's scary secrets, we are reminded of the vast, unexplored mysteries that lie within our own solar system.